Hello viewers, welcome to another video of my channel. In this video, I will be solving another SQL query that is very tricky and interesting. That's why I'm just showing how to solve it. I have taken this this SQL problem from this website, TechTFQ. I have participated in one of the bootcamp of him. So I find this problem is interesting. That's why I planned to solve this. Okay, so let's jump to start solving the problem. So now you can see the problem statement is showing on the screen. Here the input table is given. So what's the instruction here? Identify the student who always outscored themselves in each semester. Okay, let's try to understand the problem first. So we are given a table here. Some students names are here there: Esther, Nova, Mila, and their ID is given, and their semester is given. So this is first semester, second semester, third semester. So everyone has participated on the total fourth semester. So there's the semester number of them, and here's the percentage of the number of them is given in each semester. So the question asks, identify the student who always outscored themselves. That means like exceeding himself or exceeding herself. So in each semester means like the student who did better and better in each semester, like who didn't get like lower mark in the preceding or the next semester. That's the main theme. So if we check it, like Esther has got 86 in the first semester, but Esther has got 81 in the second semester. So Esther failed the condition. He didn't fulfill the condition. So now go for the Nova. Nova got 73 on the first semester, 81. He is doing better. Third semester she did 87, and fourth semester she got 85. So she did like course she did bad in the fourth semester. So this will not also be considered. Now think about Mila. So the Mila got 57 and 77, increasing 88 for third semester. That's also increasing 91 in the fourth semester. That is also increasing. So from the table, we found that only Mila got better and better in each next semester. So our outcome will be Mila. So it's showing here the output will be Mila. So we will try to solve this problem. Okay. So by solving this problem, we will get out like how Mila can be found out. Now let's go to our PostgreSQL PG admin tool. That's the thing that I'm using to solve this problem. At first, I have created already the table, and now you can see the table here. The same table I have created. Okay. Now let's start solving. Now let's try to understand the problem. Like it's saying who performed better always. So how can I do that? One thing we can think about, I think, like if somehow we can deduct each semester marks from the next semester, we will get some value, isn't it? So if we like, let's try to solve it. If we deduct 86 from 81, we will get 5. But if it would do better, then what will happen? We would get a minus 5, isn't it? Okay, let's drag the full thing, because on the next semester she also didn't do better. On the next semester she continuously did worse, this Esther. Okay, so if I start solving this thing, let's try how this will work. If I just deduct 73 minus 81, so I'm getting minus 19. Oh, it doesn't create any value because like 64 has been deducted from 73, but it is the score of Nova. So let's delete it. Okay, so we have to consider the first three records, because if I just go to the fourth record, then it will take the other one. That should not be the case. Okay, so let's take the first thing, first four. So it can be seen. Okay, it can be seen like from the first three record, he did better on the first and second semester, but on the third semester he couldn't be able to do better. If I just think about the other one, the last one, that is also like he didn't do better. Okay, so now think about this Mila, what Mila did. In the Mila's case, everything will come out as minus. So this is our first thing, to fetch the next record but next semester mark and then deduct it and to see how their mark is. Then we can decide. Also, there is a problem with the last number because the way we are taking the last number cannot be compared. But we are considering the third number, like whether the third number is more than the fourth number. This is the way we are considering the fourth, isn't it? Like whenever we are taking this thing, so we are considering this two. Whenever considering minus 11, we are considering those two, and whenever we are considering this, we are considering this 88 and 91. So if we get all negative here, for whom we will get all negative, that will be the answer, isn't it? So we get all negative here, so Mila is the answer, but we didn't get all negative here, so Nova is not the answer, and we also didn't get any positive, so this will not be the answer. So let's try to implement this on our pgadmin PostgreSQL. So what we have to do, the thing, somehow we have to fetch out the next record, isn't it? Okay, let's start solving this. Let's try select. Okay, star. I am taking all the record. There is a special function on SQL that is called window function. There is a special window function that is called lead or lag. So what lead and lag does, the lead can record on the next stage and lag can trace record or pick up the record from the previous stage. So how that works? So whenever we will use lead, let's say for example SQL processes everything like one by one. Whenever it will be processing this individual record, so if I want to fetch the next one, so we have to use the lead for the next one. Let's see how that works. So we are selecting everything from this and then we will select lead. This is a window function. What we will lead, we will lead percentage. Okay, we will lead this percentage, percentage, percentage column. Now we have to provide a value, like how many records after, like which record we want to trace or pick up. If we want to pick up the next record, we have to provide 1. If we want to pick up the next second record, then we have to provide this 2. So now we always want to pick up the next record, isn't it? So we are providing 1. So lead, but as we are using window function, we have to provide this thing over. That is, by default, we have to use it with window function, so that it takes the full table and it gives the lead as a separate record on the right side of the table. Okay, whenever we will write, we will see. And in this over, we have to provide another condition, like say for just think about, we have 3 students, Nova, Esther and Mila. So whenever we will be processing those 3 records, we should not process this fourth semester record with Nova's first semester record, isn't it? Because Esther is different. So what we will do, we will partition this, so that this Esther, this Nova, this Mila, these all can be treated separately. So we will partition. So partition by, so like we can partition it by ID, by student name. Okay, let's do it by ID. So now from student marks, if I just run it, let's see what happened. So okay, we just have run it. Okay, now we are getting the next semester marks with the first semester, like the percentage is showing in the first semester mark, the lead is showing the next semester mark, isn't it? This 81 is showing there, this 75 is showing there, this 64 will not be is showing there, but this 73 will not be taken because there is a partition. So we will not take this 74, this 73, so rather is showing null. Okay. So, okay, so that's fine. Our function is working up to now. We solved in this problem. Let's, okay, let's order it by the semester, so that it always maintains the semester serial. Okay, it is also already given here and the serial, but if it would not be given, then what we would do? We have to sort it first, then we have to consider. That's why we are providing this thing, so that it won't break even if the semester will not be in order. Okay, probably I have made a mistake. Let's run it again. SEMESTER. Okay, partition by ID and order by order by semester AC. Let's see whether it works or not. It's working. So the issue is like we should not provide any comma in between. I provided comma on that time. Now we will try to give a meaningful name. So for this column, okay. So next same next next same. So it is the next same marks. Okay. Now it's kind of meaningful. Okay. It's showing the next semester mark. Okay. So for now, what we have found the two semesters name side by side. So now we have to bring out the difference. Okay. So the difference is very easy because we have got the like through this lead function we have got the we have got the next semester mark. Now we can deduct this percentage with this next semester to got the difference. Let's go a bit front and let's put a comma and then write, yeah. Okay, now we have written this as percentage because we are taking this column, then we will deduct this full thing so that, okay, let's take it lead and we will give the name as difference because this will be the difference. Let's run it and see. Now we have got the difference between each semester and the subsequent semester, isn't it? 5, 6, 11, and then null, and then -8, -6, and 2. Now we are getting everything in order. Now from this table, we have to decide which one should I keep, which one should I not keep. So how should we decide? Just think about this thing. Like where there is at least one positive value, we will not take this, isn't it? Here's everything is positive. Here's everything is like 2 is negative, 1 is positive. What does positive mean? Because the number on the next semester decreased, that's why it's become positive, because 87 has become 80, 85 on the next semester, so it's become positive. So we are not considering this. We have to consider where everything is negative, like where each semester marks is increasing, like this one -20. So next semester he got more than 20, like 20 more. On the next semester he got 11 more, and the next semester he got 3 more. That's why it's becoming negative. So like from this table we will fetch only the records where there is no positive. Okay, so what we can do? Okay, so the we are getting null here. One thing we can do, there's another thing that we can do, like as we are getting null here, so we can replace it with something else. Say for example, whenever we get the last number, we can replace it with the last number itself. So there's also another option to provide on the lead function. Like if we provide this percentage here, then what it will do, it will take, if it doesn't get any next value as it is partition, so it will take this number itself. Let's run it. And see this 64 is showing here. Also we have to provide it so that we can get the difference. Okay, let's provide it here also, percentage. Now we are getting, this thing is nice, the last number is showing because there's no next semester number. Now we can decide whether there is any, whether there's no value more than 0. If there is any value more than 0, then we will not take it. Where the maximum value, like think about this partition. Okay, if the maximum value is 0, we will consider this. But in this partition, and the second partition for the nova, the maximum value for this nova is 2, isn't it? So we will consider only those partition where the maximum value is kind of 0. So what we can do, okay, I am just writing it with, I'm transferring this full table as CTE. Okay, CTE as, okay, so okay, let's write it here. let's shift this table on the side so that it can be understood. So I have provided everything under a CTE. Now I can, okay, let's write whether the CTE works. Select a star from CTE. Let's run it, whether our CTE is working. Okay, we have given another bracket, should not be done. So now you can see our CTE is working. Now we can work on the CTE. So select star CTE from CTE. Now think about this whole thing is a group, isn't it? A star, Nova. So we will group it. We will group it by student name. And whenever we will group it, we have to do some aggregate function. We can like sum those. Just think about, okay, let's show it. Group by student name. If I run it, it will show as wrong because group by cluster based in CTE ID must appear in group by. Okay, so CTE ID, column CTE ID. So we have to provide this ID. Okay, student name, student name. So whatever we will do group by, we have to provide it on the select statement. Diff. Okay, let's see the two columns. So what it is showing, CTE diff must appear in group by clause. So if I just provide anything here, we also have to provide it on the group by. But the fact is that we are not providing anything here. We have to provide, let's provide some. Then we will see. Now, what it is taking? It is taking all the students. It is grouping by all the students, and it is summing the last difference column. Let's see, minus 34. Okay, if we just run it. So minus 34 is Miller's summation, minus 20, minus 11, minus 3, minus 34, isn't it? Let's see. So for Miller, it's minus 34. This is the way it's working, okay? But we are not interested about this thing. What we are interested? We are interested whether the maximum value of any group is more than 0, okay? So we will take only those records where the maximum value is only equals to 0. So what we can do, we do not need this thing. Rather, we need only student name, and we will take only those having difference. Now we will take max difference equals to, so we will taking the maximum of each group. So it's taking this group Nova, and it is taking all the numbers, and it is taking the maximum numbers of the difference column, and if it is 0, it will provide us the number, the name. Let's run it. So we are getting Mila here. That's our desired answer. So what it is doing, okay, let's run this again so that you can understand. What it is doing, it is like from this CTE, it is considering the full table, and those full table, it is grouping by the student name, and from this is each group, it is considering only where the maximum value of difference column is 0. So for this star, the maximum value for difference column is not 0, it's 11, isn't it? So it will not fetching this. For this one, for Minova, maximum value is 2. So it's not fetching, but only for this the maximum value is 0. That's why it is fetching only this thing. So this is the way we can solve this problem, and it's a pretty interesting problem. We are using a window function, and we are using some logic to solve this. So that's all for now. If you like this video, or if you find this problem as interesting, you can give a thumbs up, and you can share this with your friends and on your network. And if you have any question, you can ask me. I can try to further clarify. And also you can watch other videos of my channel. And if you are interested to learn those things like this data analysis, data science, or even like machine learning things, you can subscribe my channel. Thank you so much for now. See you on next video. Bye bye.